Hey friends, we're back. So I wanted to show you, it talks about in the article how Fibonacci ended up using Arabic numbers instead of Roman numbers, I think is what the article says. They're also known as Roman numerals. And so this is the way numbers, were written, and these are the Roman numerals, but Fibonacci used these numbers, which they're called Arabic or Western Arabic or Hindu Arabic numbers because there's Eastern Arabic numbers, which look different as well. But this is the way Fibonacci wanted to record the numbers. And then I thought this might give you a better idea of the patterns that's like spread out for you. So you've got 1 plus 1 equals 2, then 1 plus 2 equals 3, 2 plus 3 equals 5, and so on. And I'm not giving you a math lesson, but I just wanted you to be able to see the sequence or the patterns that they're talking about that he figured out. And he figured out these patterns by looking at the things in nature, the snail shells, the flower petals, the middle parts of the flower, the pine cones. And this is what he discovered. Okay, so back to the article and the questions. Not petroglyphs, but Fibonacci. So, what would be the best summary for this article? A. Fibonacci's dream was to develop mathematical equations that would explain nature. Sadly, in the end, his only real contribution was to change from the Roman number system to Arabic. So I'm thinking that it doesn't say anything about Fibonacci's dream being to develop mathematical equations. And it doesn't say something that makes me think it's sad that the only thing that he did was change Roman numbers to the Arabic system. So I'm going to say no for this one. B. Fibonacci spent many years counting spirals in shells and petals in flowers, then made up an addition sequence that generated the numbers he had found. So generated means like made the patterns, made those sequences, the 1 plus 1. What other examples? 1 plus 1 equals 2, 1 plus 2 equals 3, that. So I think maybe this might be the answer, but I want to read the third one again just to make sure because the article does talk about how he counted the things he saw in nature, and because of the things he observed in the plants, he came up with these mathematical equations. And letter C, Fibonacci developed a mathematical sequence of numbers. We know now that the numbers in the sequence appear often in nature, while numbers not in the sequence do not. So it doesn't say in the article that other numbers don't appear in nature. It does say it's harder to find flowers with these 4, 6, 7, or 10 petals, but it's not saying that it's impossible. So here it's saying while numbers not in the sequence do not, and that's not true. So the answer for number 1 is B. Okay, number 2, what are Fibonacci numbers? A, numbers that follow a very specific pattern. I think maybe it could be that one because in the article it talks about these patterns, 3 petals, 8, 13, or even 21. It's harder to find these numbers, but there's something special about 3, 5, 8, and 13. And then it goes on to show the math. So maybe they follow that pattern. Or B, numbers that are written as Roman numerals, not 1, 2, 3, 4. I know that. No, those are not Fibonacci numbers. That doesn't matter whether they're in Roman numerals or Arabic numbers. Or C, any numbers that can be found in nature. And I know that that's not true either because it talks about other numbers, like the 4, the 6, the 7, and 10, and those aren't Fibonacci sequence numbers. So I know that the answer to number 2 is A. They follow a very specific pattern. All right, and number 3, you find a flower with 4 petals. Using information from the book or the article, what could you infer? A, the flower is very rare and should be shown to scientists. B, the flower originally had 5 petals but 1 fell off. And C, scientists have been incorrect about the relationship between Fibonacci numbers and flowers. Okay, so C, I know that C is not it because it doesn't talk anything about scientists being incorrect about the relationship between Fibonacci numbers and flowers, and that's not what the article is about. It's about these patterns in flowers and what Fibonacci discovered and what the Fibonacci numbers are. So it could be A. If you see a flower with 4 petals, maybe it's very rare and it should be shown to scientists, or the flower had 5 and 1 fell off. So I'm going to go back up here and remember when I told you to pay attention to that part? It says here, but it's harder to find flowers with 4, 6, 7, or 10 petals unless some have been nibbled by animals or insects. So it's saying maybe it had a different number of petals, but something happened to one of the petals. It was eaten by animals or insects. So I can infer that the answer for this is letter B, that the flower originally had 5 petals, but 1 fell off. If I find a flower with 4, I can assume that the flower had 5 petals, but 1 fell off, because that makes the most sense. Not that it's extremely rare and should be shown to scientists. So we're going to work a little bit more on summarizing. So we're going to go back and look at the article again, and it's hard to chunk this up into paragraphs, but I've chunked it up into what I think the paragraphs should be. And we are going to summarize each paragraph. So the summary is when you want to get the main idea out of the paragraph or out of the article or out of the story and make it simple. Like if someone asks you, hey, what is the book about? And then you can tell them in 3 to 5 sentences what the book is about, or what's the movie about, and you want to summarize it. So you want to tell somebody or write about the main points and not give extra details that aren't necessary. So in this first paragraph, go count the number of petals on the flowers in your backyard, out in the country, or in a picture book. Did you notice that the number 5 keeps coming up? Buttercups, pansies, tomato blossoms, and geraniums all have 5 petals. So, how would I summarize that first paragraph? Whoops. I would say that many different kinds of flowers are made up of 5 petals, because that paragraph is specifically talking about those certain examples of flowers that have 5 petals. So this would be how I would summarize that first chunk in the article. Many different kinds of flowers are made up of 5 petals. Okay, go back to the article. You may also find flowers with 3 petals and others with 8, 13, or even 21 petals. But it's harder to find flowers with 4, 6, 7, or 10 petals, unless some have been nibbled by animals or insects. Is there something special about the numbers 3, 5, 8, 13, and 21? As a matter of fact, there is. And then it talks about these math equations. And so for paragraph 2, I'm thinking that it's important, these numbers are important. So I think it's important to note that there are numbers 3, 5, 8, 13, and 21. And so the way I'm going to summarize that paragraph is to say that There may also be flower petal patterns in numbers of 3, 5, 8, 13, and 21. Because in the first paragraph we talked about how there's just 5, but then in the second paragraph it goes on to explain that it's not just 5, it's these other numbers as well. And for the sake of time on this video, I'm going to go ahead and do, well, I think I've got time. We'll go back. And then, so it tells you about these patterns in the flowers, the number patterns, and then it tells you about Fibonacci. And these are called Fibonacci numbers. They're named after a mathematician, Fibonacci. He lived in Pisa, Italy, which is in Europe. And if you've seen that tower that leans kind of sideways, that's the Leaning Tower of Pisa, that's where he's from. And it's saying he was probably the greatest mathematician of all time because of this sequence that he discovered. So for my summary for this next section, I'm going to say Fibonacci was an Italian who studied math. I could have also said Fibonacci was an Italian mathematician. Either one would have been fine. He discovered these patterns in nature because what he discovered became important in math, and he was able to apply these things that he saw in nature with math problems. And that is what that paragraph is telling us. Then on the last one, he was the first European to use the Arabic number system instead of the Roman number system. Fibonacci numbers show up all over nature. They are in the spirals of pine cones and pineapples, in the swirls of snail shells, and in flowers and leaves. It might have to have something to do with how plants and other living things grow. If so, math and nature work very closely together. So in my opinion, it's not if so. It's totally obvious that science and nature are working together. Math and nature are going together. Like there is pattern and design. It's not just random. So in paragraph 4, Fibonacci's discovery of these patterns in nature is important because it shows that math and nature work closely together. So we have just summarized the whole article by each paragraph. So we've got many different kinds of flowers are made up of 5 petals. There may also be flower petal patterns in numbers of 3, 5, 8, 13, and 21. Fibonacci was an Italian who studied math. He discovered these patterns in nature. And Fibonacci's discovery of these patterns in nature is important because it shows that math and nature work closely together. So right there, I have a summary paragraph. What the whole article is about. I give you the key details. Like I don't even talk about the Arabic number system and the Roman number system because that is a detail that's not super important to the whole idea of the article. So your turn is you are going to write a summary for the flower numbers article. You can use all the sentences from this slideshow and just put it into a paragraph in your notebook or on a piece of paper. Or you can write a summary in your own words and use the sentences from this slideshow as an example to help you. So you can make up your own summary and you can use what we just did together as a model to help you do one in your own words. So that will be your assignment from this article. And you can send pictures of it to your homeroom teachers to check. Either text photos or email the photos to show your teachers the work that you've done. And they can check it and see how you did on your summary. So thank you so much for listening, and I hope that you have a great week.